Welcome back again. In this series of videos, we're going to take a look at software-defined networks, and we're going to start with the discussion with to look at how the traditional networks are currently the problems we're trying to solve in the traditional networks. We know that the Ethernet is a predominant way of connecting in the enterprises, and it uses broadcast that, and it's a VLAN based really infrastructure that we have in spanning tree. Obviously we're using spanning tree to connect various elements of the layer 2 broadcast. It's loops can be one of the problems, and managing the layer 2 segments, and having the configuration decentralized on each switch and the various elements of the network. That's also one of the issues we have with traditional networks. Monitoring and of the networks done through more of the NMS and decentralized. So IT industry is consistently changing and evolving. The time goes on. There is an ever increasing number of technologies putting strain on the network. So therefore, the new paradigms are formed, and as other um, networks have been shifted, new advances have been developed and adopted within the network technologies. So therefore, we need to look at traditional network in a way that we have traditionally core distribution and access networks. So let's say that if we had endpoint connected in our traditional networks, PC1, 2, 3 in our traditional fabric, and suppose that the PC1 was in VLAN 10, PC2 was in 20, and VLAN 30, and so on. The communication traditionally is up the access to the distribution back down to the access, and there's no edge-to-edge communication. Traditionally, layer 2 trunks would take the traffic up towards the distribution, and if the traffic needs to go across to the other subnet, that would traditionally go to SVI, that is in a normal designs in the core networks, and for any of the access outside the traditional enterprise network would connect up to the core and go outside to the internet or over first hop. Redundancy protocols like HSRP, VRRP are also configured at the core node. So traditionally you see the traffic has to traverse from one VLAN to another via the SVI up to the core, via trunks back onto the distribution networks. And looking at from the spanning tree perspective, it's a root bridge is normally the core of the network. So the traffic is sent across the cost space. So in STP, the chances of loop happening on a multiple links when we have the layer 2 bridges connected. Similarly, if you look at for example, HSRP and etc. are utilized to give a backup to the gateways that to send traffic out of the enterprise network. So these are some of the issues that actually stopping the enterprise network to scale up to a new level that we want. So mobility is one of the other issues that we have. For example, if the end user of a PC1 or a laptop moves to another switch, traditionally they connect to edges, but let's say for some reason someone moves to another switch up in the distribution layer, you'd have to connect it to manually that particular VLAN and ensure that all the access connectivity is there. And similarly, the APs are connected traditionally to the access layers, and mobility is based on the WLCs, and this is a more rigid format. So we need to look at what SDN offers us in terms of models. So SDN basically based around underlay and overlay technology. So we've decoupled the control and data plane, and from policy plane. So the most common description of this is separating the control plane from data plane, having a controller that sits on top of the rest of the devices, so to speak. So gives the advantage of taking a step back and operating the network as a whole from centralized management point. So we look at the policy plane is separate, that is implemented through ACI, and automation is much more quicker and easier, and we are able to remove the vendor lock. So the CLI is not designed to make the massive scale configuration, so that part is also addressed in the fabric. So when we look at the Cisco fabric, so we have the Juniper and VMware fabrics, but just to have a look at some of the common fabrics. So underlay is built as layer 3 point-to-point links. So in the fabrics, an IGP is used to have the layer 3 connectivity between all the fabrics components. And in Cisco's SDN model, we're using ISIS as the IGP in the underlay, and Lisp is running as the control protocol for the mapping of those layer 3 links. So the edge switches towards PC is layer 2, layer 3. So ISIS acts as a underlay IGP, Lisp as a control plane for the control plane, and VXLAN is a data plane for the both layer 2 and layer 3 in the Cisco version of SDN fabric. So the connectivity is layer 3, Lisp again running as the protocol to map, and finally VXLAN is encapsulating the packet in the data plane. So this sort of a SDN model, underlay, overlay, and policy based, is implemented across the vendors like Cisco, Juniper, HP, and VMware, and we also able to remove any of the vendor lock as well. In this series, we're going to take a look at Cisco SDS. So let's wait for that video next. Thank you for watching.